Hi everyone, and welcome to Mod 8 of MA 215, which is Applied Statistics at Bellevue University. Again, I'm Professor Brame, or Professor B. This week we are going to start our study of inference. So last week we had an idea of what the central limit theorem was, and using that to then make decisions. So this week we're going to take it a step further, and we're going to look at confidence intervals and hypothesis testing. So the rest of this course will focus on those things for different values. So in this video, we are going to learn what a confidence interval is. So it's just going to be sort of a brief overview, and then we're going to delve into different parts of the interval, and then we'll put it all together when we actually construct confidence intervals. So first of all, let's talk about inference, because inference is really what we're doing. Inference is where we're going to make predictions about the unknown based on information that we collect. So it's not just guessing. And typically we don't know what to expect out of the population. So what we're going to do is we're going to look at those samples like we did last week, and we're going to find samples, and we're going to look at the statistics from those samples to then make decisions. So this week we're going to focus on proportions. Module 9, which is next week, is focusing on inference with means. And then our final lessons, which is Module 10, inference will be based on two samples, so either two proportions or two means, and how we handle that. So we learned last week that a sampling distribution with p hat is centered at p. So what we did last week is we looked at our p hats. We looked at what we were expecting to or what we actually found to happen, because remember, this is our actual data. But it was centered at P because we said that we expected 33% of Bellevue students to like the food in the food service. So that always went in the middle, and then what we actually found kind of made this bell curve on the outside. And then of course we used our standard deviation, which was PQ over N. And remember, P, that was a population proportion. So that's if we already knew what we were expecting to have happen. But in the real world, that's just not realistic. We have no idea what's going to happen. Presidential elections, we've got one coming up, and let's not get into that. But most of the time we don't know P, and so what we do is we find data, so we know our P hat, and we'll use that data to then make predictions about what is really going to happen. So this is all about things that actually happen in the real world. Now, last week we found the standard deviation by PQ over N and then the square root. That's how we found the standard deviation. This week, typically we're not going to know P. We don't know what P is, and so we're going to have to use P hat. So we're going to use P hat Q hat over N, and now we're going to call this standard error. We call it standard error because it's a little bit less precise than if we actually knew the real population parameter. So again, using the empirical rule, which we learned again last week, we said about 68% of all samples have our observed value within one standard deviation of P. But now we're going to call it standard error. And about 95% of all samples will have our P hat within two standard deviations of P, and 99.7 within three standard deviations of P. But now we're going to flip it around, because remember, we don't know P. So now we're going to say, all right, let's have P hat in the middle. So if we look at it from P hat's perspective, and we're trying to find P, because that's our goal, is to find what is the actual population parameter. So now we can say, two standard deviations away from P hat, we're 95% confident that our P is within two standard errors of P hat. So now instead of having P in the middle, because P is unknown, we put P hat in the middle. We put our observed value right in the middle, and we say, we don't really know what to expect, but we know that there's a 95% chance that our actual P value is going to be within two standard errors of P hat. This is called a 95% confidence interval. So we're going to create confidence intervals. We're going to find what is this value and what is this value. We're going to say we're 95% confident the actual population parameter is within that interval. So again, it's just a range of values that we believe contains the population parameter. So if a weatherman is 95% confident we're going to get between 4 and 8 inches of snow, he believes there's a 95% chance we're going to get somewhere between that, but he doesn't know the exact amount. But of course, we all know, especially if you live in Nebraska like I do, that quite often they are wrong. And so there's always that chance on the outside that the weatherman was wrong and we now get 8.5 or 9 or 12 inches. So each confidence interval uses a sample statistic to estimate the population parameter. And what that means is that if I made a confidence interval based on data that I collected myself, and then you went and collected data, and of course your sample is different than mine, that's called sampling variability, your confidence interval would not be the same numbers as mine. So here's what that looks like. Say this was my confidence interval. And notice my confidence interval, this is P, this is the real proportion, which most of the time we don't know. But notice if I make a confidence interval, my sample didn't include that P value, or didn't include P. Now yours is right here, and notice yours, this is the actual sample statistic you found, and then of course this is the interval that you found, and yours does contain P, and this one does, and this one does, and this one does, but this one does not. So it's, what we're saying is, hey, this is an unknown, we don't know P, but we're 95% confident that when we create a confidence interval that the actual P is going to be in that interval. So again, this is just, I'm going to interpret this. We don't really know how to do all of this stuff yet. We're going to talk about it more in detail in a little bit. But a confidence interval in general is our P hat at the beginning. So P hat, and then plus or minus, we've got a number here. We're going to use 2 for right now because 2 standard deviations. This will change later. But then this is times the standard error. And the standard error is the P hat Q hat over N. So if I calculate standard error and I calculate P hat, which of course is just 52 out of 148, then if I'm using the normal model, my 95% interval would be P hat minus 2 standard errors times P. So that's 2 times 0.0392. And then plus 2 standard errors times P hat, which is 0.4298. So this is my interval. This is what I'm saying I would expect to see. I'm 95% confident that the actual number of Facebook users that update their status daily is between 27.3% and 42.98%. That is what I can say based on this interval. Notice I'm basing it off of my 52 of 148, which is what I found. Now, if you went out and talked to 148 of your Facebook friends and found out if they updated their status, or random people, which would be better than just your friends, then you would get a different P hat and therefore a different confidence interval. So again, this is very important. There are things that we can say and things that we cannot say based on our confidence interval. So I can say that I don't know the percent of Facebook users that update their status daily, because that would be P, and we don't know P. But we are 95% confident that the interval from 27.3% to 43% contains the true proportion. So that's what this interval means. Or we're 95% confident that between those two values of all Facebook users update their status daily. Here's what we can't say. We can't say that 35.14, which is what I found when I divided my two values, that is the amount of all Facebook users that update their status daily. I also don't know the percent of Facebook users that update their status daily, but I know that it's within this range. And that is not true either, because we don't know. We're 95% confident that it's within that range. Now for this lesson, we're working with a 1 proportion Z interval. So as we move through the rest of these modules, there's going to be a lot of different names that I'm throwing at you. So 1 proportion, of course, means that I'm dealing with a proportion rather than an average. And then Z interval, I'm using Z because this is going to be a normal model, and therefore I'm going to be using Z scores and the normal CDF, or using StatCrunch with normal.